Okay. Hello, everyone. We are going to see a Murray model for the bit pattern 101 in the case of non-overlapping. So, what are the steps we need to follow to solve such problem? First step is to draw the state table. Draw the state diagram. Second step is draw the state table, and along with this state table you have to also draw the of excitation table of the particular flip-flop that you are going to use to design the Murray model. For example, I am designing the Murray model by using the D flip-flop, so I will use the excitation table of D flip-flop. Clear? If you are using the JK flip-flop for designing the circuit, then you have to use the excitation table of JK flip-flop. In the third step, you have to draw the K map for finding the expressions for D flip-flop. Okay, so here we have to draw the K map. In fourth step, we will draw the circuit diagram. So now let's see for this particular question how to start making the state diagram. And the state diagram is actually the most important part in case of the Murray model. So let's see for 101 how we can make a Murray model. So, so here state diagram is started with the initial state A, and we have to write down the output also. What is the way of drawing the state diagram in Murray model? Here we write down state divide by output, then next state divide by output, and here we write down at the center we write down input. This is the way of representing in the Murray model. So we are initializing the state A as we have not received a single bit correct. That means output is 0. Whenever I will receive a single bit correct, that is 1, I will move to the another state that is B, and output is 0 because we have not received a correct pattern. Whenever you receive the correct pattern, then only your output becomes 1. Now, after B state, if you receive 0, 0 is the second bit correct, then you will move to the C state, and here also your output is 0 because we have not received a correct pattern. Now, after this, if you receive the third bit correct, that is 1 here, you will move to the D state, and here your output becomes 1 because now here you see 1 0 1 we received the correct pattern. That's why your output becomes 1. Right here we are having one extra state if you compare with a Mealy machine, because here the output is represented along with the state. Now as we have drawn for the correct bit patterns, now we will draw for the wrong also. So for the wrong, that means if you are in the state A and if you are getting 1, that means we received single bit correct, that's okay. But what will happen if you are getting 0? 0 if you are getting, that means we have not received a single bit correct because my first bit is 1. That means you are in the initial state only, and here you write down if you get 0. Here I am writing here, if you are getting 0, that means we have not received a single bit correct. Now if you are in the state B means we have a single bit correct, that is 1. I am having the single bit correct 1, and I was waiting for 0. If I will get 0, I will move to the C state. But what will happen if I am getting 1 1 continuously? If you are getting 1 1 continuously, that means we have a single bit correct. I want 0 1 to complete the pattern. So what does it mean? If you are getting 1 1 1 continuously, also you have one bit correct in this situation also. Single bit correct state is B, so that means you have to remain in the same state B, and here you write down 1. Now you are in the state C. What does it mean? You are having 2 bit correct, that is 1 0. You are waiting for 1. If you get 1, you will move to the D states. Okay. But what will happen if you are getting 0 here? If you get 0, that means complete lost of pattern because I want 1 0 1 after that also. That means we don't have a single bit correct. No single bit correct means what? Initial state. That means you have to move to the initial state. Here I am writing 0. Clear? And now I'm removing these things because this is not required in the state diagram. This is just for understanding. Now, if you are in the state D, if you are in the state D, and this is the non-overlapping. Okay, non-overlapping means what? 1 0 1. Okay, if you get 0, 0 means complete lost of the pattern, right? This is the that means we don't have a single bit correct, because after that also I want 1 0 1. That means whenever you receive 0, you have to come back to the initial state, and that is what? A 0. Okay, and now after 1 0 1, if you are getting 1, after 1 0 1, you are getting 1. That means how many bits are correct? 1 bit correct, right? After 1 0 1, if you are getting 1 here, that means 1 bit correct. After that I want 1 0 0 1, right? So what does it mean? I have a single bit correct. If I get 1 here after D, single bit is incorrect, and single bit correct state is B. That means you have to move it like this, D to B, and here you write down 1. So this is the case if you are taking non-overlapping case. Okay, this is the non-overlapping 1 0 1 state diagram for 1 0 1. Now if you are ready with the state diagram, we can draw the state table. In the state table, we require certain inputs that are present state. So here you have to write down present state. Then here you write down input, and input will be represented by X. Then you have to write down next state. Then here you have to write down output as Z. Okay. So now here, how many states we have? We have 4 state A, B, C, D, right? Here you write down A, B, C, D. So this is A, B, B, C, C, D, D. Input can be either 0 and 1, because if you see at any state, we have two options. Either you get next input as 0 or 1, right? So that's why you have to write down all the possible combination here also. So here I am writing 0, 1, 0, 1, 0, 1, 0, 1. Now, if you are in the state A and your input is 0, what will be the next state? That we have to find out. If you are in the state A and you are getting, if you are in the state A and you are getting 0 as an input, next state will be A only, right? Here you can write down A. Now, if you are in the state A and you are getting input as 1, if we are in the state A and you are getting input as 1, next state will be B. So here you can write down B. Clear? Same thing you have to do for the other state. If you are in the state B and you are getting 0, what will be the next state? B to 0. So B input 0. So you have to move to the C state. You just write down here C. Likewise, you fill the values here B, A, D, A, B. Just you have to go to that particular state and check if input is 0, what will be the next state. Clear? Now, here, as you know that in the digital system design, we cannot represent anything by the alphabets. We have only binary number system because everything is binary. So as we are having 4 state A, B, C, D, we require 2 bits to represent every state. So here I am representing A as 0, 0, B as 0, 1, C as 1, 0, and D as 1, 1. Clear? As we have represented A as 0, 0, here also you represent 0, 0, A is 0, 0, A is 0, 0. Similarly, I am representing B as 0, 1. So this is 0, 1, this is 0, 1, and this is also 0, 1. I am representing C as 1, 0, so 1, 0, and D I am representing as 1, 1. Now you see I filled all the details here. Now, what will be the output? See, as the output is there with the state and D by output, right? So that means whenever you move from D to B or D to A, your output becomes 1, because here in the Moore machine, output is indicated along with the state. So whenever you move from D to any other state, your output becomes 1. So now here, when you are moving from D to B, output becomes 1. And whenever you are moving from D to A, then also it becomes 1. So D to B and D to A. So D to A is 1, D to B is also 1, and rest all other conditions is become 0. Clear? Now, as I told you in the beginning also, we have 5 steps, and along with the state table, we have to draw the excitation table of D flip-flop. If you are using D flip-flop for the designing, if you are using JK flip-flop or T flip-flop, you have to use the excitation table of that particular flip-flop. For example, here I'm using the D flip-flop, so I need the excitation table of D flip-flop. Here I am considering Qn, this is Qn plus 1, and this is D 0 0 1 1 0 1 0 1, and the output becomes 0 1 0 1. The good thing if you are using D flip-flop is what? Whatever will be the next state, it is similar to that of D, right? So here I am considering this is Q1 and this is Q0, for example. So the next state will be represented as Q1 plus 1 and this is Q0 plus 1. Just this is the representation. That means it's a present state and this is the next state. Now here you have to compare the present state, that is Q1, with Qn plus 1 and find out the value of D1. Okay. So as we have seen in the excitation table, that whatever is the next state, it is similar to that of D, then here also you can use the same thing. So here D will be the Q1 plus 1. That means 0, 0, right? Q1 plus 1, 0, 1, 0, 0, 1. This is 0, 0. Similarly, what will be the value of D0? Q0 and Q0 plus 1. From the excitation table, we know that whatever will be the next state, it will be equal to D. So here you will get 0, 1, 0, 1, 0, 1, 0, 1. Now this is the complete state table. After that, we have to draw the K map to find out the expression of D1 and D0 in terms of Q1, Q0, and X. So here I am going to draw the K map for finding the expression for D1, and here I am taking Q1 this side, Q0 and X this side. As in the K map, we are using the gray code 0001101110, right? Now you see wherever your function value D1 is 1, you fill it here. So D1 is 1 for 1, 2 conditions. Okay, so now here it's D, this is 0 1 0 and this is 1 0 1, 0 1 0, 0 1 0 and 1 0 1. These are the two conditions for which your D1 is 1, right? Here you also check once. Here D1 is 1 when it is 0 1 0 and again it's 1 for 1 0 1. So I filled it here for 0 1 0. This is 0 1 0 and this is 1 0 1, right? And from here, as we can check, we don't have any group here, so we can write down individual terms for here. D1 will be represented for this expression as Q1 and this is 0 1, so this is Q0 bar X plus, it is also individual term, this is Q1 Q naught, Q1 bar Q naught X bar. So this is the expression for D1. Now we will draw the K map for D naught. So now here in D naught, again we have a 3 variable K map. This side I am taking Q1, this side I am taking Q naught X. This is 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, because it's using the gray code here. Now here you see, wherever your function value is 1, like 0, 1, 0, 1, that means, see, this is 1, 2, 3, 4, right? So now here you see, it is 1 for 0, 0, 1, 0, 1, 1. Okay, 0, 0, 1, 0, 0, 1, 0, 1, 1. Next, it is 1 here, 1, 0, 1, and 1, 1, 1. 1, 0, 1, and 1, 1, 1. 1, 0, 1, and 1, 1, 1. That makes a quad here, and expression for D naught will be X. So now we have the expressions here, and we have to use it to draw also. Yes, more important point, it's the requirement of Z expression. Z is your output, and for that also we have to draw the 3 variable K map like this. This is Q1 and this is Q naught X 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Now, what is the expression for Z? Here you see in the excitation table, Z is 1 twice, 1 for 1, 1, 0, another one is 1, 1, 1. So 1, 1, 0, 1, 1, 0, and 1, 1, 1. Now make a pair here and we can write down the expression as Q1 and this is Q naught. This is the expression of Z. These 3 expressions we require to draw the circuit diagram. Now here I am drawing the circuit diagram for it. So how to start? First you draw the D flip-flop, 2D flip-flop, right? Because we were having the 2-bit for the state representation. So we require 2D flip-flop. Here I am writing D1 and this is D0. This is D1 and this is D0. And from here you will get Q1, this is Q0, and the Z expression is AND operation between Q1 and Q0, and that will be Z. And as this is a synchronous circuit, we have to provide the same clock to all the flip-flops. So this is the clock. What is the expression for D1? D1 is given by this expression, right? Q1 Q0 bar X. So here we require 2 AND gate like this, and then 1 OR gate like this. 3 terminals, 3 terminals. Okay, this is Q1 Q0 X, and here you write check what is the expression here. It is Q1 Q0 bar X, right? So here you change to Q bar. Clear? Similarly, here I am writing Q1 Q0 X and also checking what is the expression. Here it is Q1 bar Q0 and X bar. So this is bar and this is bar, right? After that, it will be given to the OR gate, and that is your D1. What is D naught here? D naught is X. So here you can write down X. So this is the diagram for 101 in the case of non-overlapping. 101 non-overlapping. Thank you.